Hi, this is Danielle, and I'm going to be showing you how to construct task number 2. This task corresponds to the 8th grade geometry standards, which asks students to explore the effects of transformations, such as rotations and reflections, on polygons, figures, and points. In this task, students are asked to construct an irregular polygon and label its vertices. They are then asked to find the image of that polygon under a 180-degree rotation and under a reflection of the same original polygon. The goal is to try to figure out when the image of the rotation of the original polygon corresponds with the image of the polygon under a reflection. To start, I'll show you an example of an irregular polygon that you can create that will not have both rotational and reflectional symmetry. I can create polygon A, B, C, D. Specifically, this is quadrilateral A, B, C, D. And I can use GeoGebra to rotate this image around the origin. So I can go up and place a point on the origin, which is point E, and then I can rotate the quadrilateral 180 degrees about the origin, and you'll see that it creates a new quadrilateral A prime, B prime, C prime, D prime that is now in quadrant 3. I can then take that same original quadrilateral, and reflect it about the x-axis. So I select that quadrilateral, select the x-axis, and quadrilateral A prime 1, B prime 1, C prime 1, D prime 1 is in quadrant 4. And you'll notice that these two resulting quadrilaterals do not correspond. In fact, they are mirror images of one another, and they are in two different quadrants. So while this quadrilateral did not have rotational and reflectional symmetry, I can manipulate the quadrilateral a little bit in ways that show us that it is possible. So if I continue to play around with this quadrilateral, I might notice that as I move the points to different locations, the images get closer and closer to corresponding until they actually do. So this image appears to correspond, but if we look more closely, we'll see that point A, or vertex A, while it is reflected across the x-axis, it's actually rotated over around the origin, and so it shows up as A prime right here in the corresponding image, and A prime 1 in the reflection right there. And the same is true for each one of these points. So why is this true? And does this figure actually have rotational and reflectional symmetry? We can explore this a little bit more by looking more closely at the points one at a time. So I can delete this quadrilateral, and let's just focus on points A and B. So if I delete those points, you'll see there's A prime 1, B prime 1, A prime, and B prime left. So you'll notice when I focus on just points A and B, that point A is reflected across the x-axis to point A prime 1, but when it is rotated 180 degrees about the origin, its rotation is in quadrant 4, point A prime. So this shows us that in order to create an image that has both rotational and reflectional symmetry, we need to make sure that the figure has point A reflected across the y-axis so that it is symmetrical, and that line of symmetry is the line on which the figure is actually rotated and So what do I mean by that? We need to reflect point A across the y-axis to form point A prime 2. Now, if I move point A, there is a corresponding point within the figure that then matches up with both the rotation and the reflection of point A. So if I move point A to -5, 5, there is a reflection at -5, -5, and a rotation of 180 degrees at 5, -5. But those same points are corresponding with the mirror image of point A reflected across the y-axis at 5, 5. So no matter where I move that vertice, there is a corresponding vertice. The same is true for point B. If I reflect point B across the x-axis, so I select point B, I'm going to reflect point B across the y-axis. I'm sorry about that. So let me clarify. Point B reflected about the y-axis, you'll see it creates point B prime 2. And then if I go to move point B, wherever I move point B, there is a reflection and a rotation that are that correspond. So how can we create an irregular polygon that we can ensure has both rotational and reflectional symmetry? Well, let me start over with a clean area. Let's start with a point, any point. We'll call it point A right here. We need to make sure that our polygon has at least one line of symmetry. So we're going to reflect point A across the y-axis. So the y-axis is now our line of symmetry. I need to ensure that every point that I create can be reflected across the y-axis because they all need to share points of symmetry. So here there's triangle ABC, and I'm going to reflect point B across the y-axis and point C across the y-axis. Now I can connect these three vertices to create, these 6 vertices to create an irregular hexagon. Now, if I reflect this entire polygon across the the x-axis, you'll notice that the figure is the exact same as if I rotate the figure about the origin. So if I rotate this about the origin 180 degrees, those images correspond. But it's very important that we're rotating about the origin and not rotating about a point that's not along that line of symmetry. So if I'm trying to rotate about point E and I go to rotate this quadrilateral about point E 180 degrees, you'll notice that those images no longer correspond. The same can be true of any irregular polygon. So I can create point A and point B and point C and point D. As long as I make sure that these points have a line of symmetry. So let's reflect all of them about a line. Create the line here. We just need to reflect each one of them about the line. I can create polygon A, B, C, D, D prime, C prime, B prime, A prime. As long as I reflect that polygon across a line that is perpendicular to the line of symmetry. So let me reflect this polygon across this perpendicular line and make sure that I rotate the same quadrilateral 180 degrees about the intersection of that line of symmetry and the line of reflection. So 180 degrees about point G, they will be congruent. They will correspond